Welcome to Feature Fridays. My name is Guy Bartram, Director of Product Marketing for our Cloud Provider Business Unit. Today I'm joined by Bhaskar and Amit. Welcome, guys. Thanks a lot for joining Feature Fridays. Let's just start with a quick round of introductions. Bhaskar, why don't you go first?
Sure. Hi, Guy, and hello, everyone. Thank you for having me for this session. My name is Bhaskar Gupta. I'm working as a technical product manager for Cloud Service Business Unit, and I work mostly on the VMware Cloud Director part, VMware Cloud Provider Lifecycle Manager, and Zero Carbon Committed as well. Thank you so much, Guy, for having me in the session.
You're welcome, man. Thanks for your time today. And Amit.
Hi, Guy. So I'm Amit. I am working as a product marketing manager in the Cloud Infrastructure Business Unit.
Thanks, Amit. And we're here today to talk about an exciting new calculator that we've created. I'm sure everyone is very aware about how sustainability is becoming front of mind for basically all of our supply chain, right? I mean, we've got partners whose customers are looking for partners who have got sustainability initiatives. And that's where VMware created the Zero Carbon Committed program. So we could recognize providers who have got a commitment to meet a net zero carbon footprint by 2030. And for some providers, that's harder, and depending on where you are, harder in other areas than it is for some others. And we've built in some programs to try and help providers start realizing their renewable energy goals, such as our SEBA program that we sent out to all our cloud providers in June. And we also wanted to kind of look at the effect that our software, our cloud provider software particularly, has on sustainability. We all know, like, moving from physical hosts to virtualized resources with vSphere, that saved a ton of carbon offset by just virtualizing the machines. Virtualizing our additional products like NSX, for example, virtualizing the network devices, and VCD particularly, when you consider those with all of the allocation models we've got a really nice offer to talk to cloud providers about, and to have them also talk to their customers about how the cloud that they're developing or the cloud that they're running can help the customers meet their sustainability goals and really jumpstart that sustainability initiative within the customer or within the partner.
Right.
So, Bhaskar, why don't you take us from the top then? This new calculator, what is it all about? What does it mean?
Sure. Hello, everyone. So to start with, these are the agenda for today's session. We'll start with a quick introduction, followed by a demo. Talk about this calculator. So our main goal behind this calculator, to address some of the day-to-day challenges, or I would say the core challenges which we are trying to solve right now. For example, this calculator basically analyzes the needs with the VCD based subscription model. For example, if you have a data center, a vCenter server, this will analyze like what are the subscription over subscription or under subscription of resources which are going on in your environment, and then it will suggest the best possible resource optimization. And it uses the VMware Cloud Director-based subscription model for the data center, and then it suggests that what exactly is your resource allocation should be, and hence it also helps in saving the carbon footprint. So I know this, is how it relates to the numbers for carbon emission. We'll be talking in the upcoming slides as well, that how it analyzes the oversubscription and undersubscription of your resources, and then suggests the best subscription model, and then comes with the carbon calculation here. So right now, this tool is based on HTML5, and there are a couple of inputs which we are requesting, from this tool. For example, you need to provide the infrastructure details, like how many numbers of hosts which you're using, what are the VMs you're using, what are the current CPU memory, and so on. And then based on that, it suggests the resource requirement or avoidance with VMware Cloud Director and also NSX. So there are, tell me.
Sorry, so this isn't looking at like the vSphere kind of optimization with sustainability. It's taken that as, all right, we're already optimizing the workloads. We've already got hosts running, I don't know, 30 workloads or whatever. This is the additional gain that you can have from running BCD and NSX.
Right.
Exactly, that's right. Yeah. Also, we'll be asking some of the physical infrastructure details, how many hosts you're using, what are the, level of throughput, and also CPU memory, as I said, and networking details as well. Mm-hmm. Based on that, we calculate all the outputs.
Okay.
So what are the benefits if you are want to talk about it? The providers basically who are zero carbon committed or they're planning to have an energy efficient data center can use this tool basically to analyze or reduce their carbon footprint. So this tool can be really beneficial for them. And because if you see in the upcoming slides and also in the demo, we have got a nice output screen, or I would say a download page wherein you get a report. It gives you a clear picture what's your carbon emission right now and how much you have saved. So this will be really helpful for the providers going forward.
And also, Bhaskar, as well as like using it as if you're a provider using it to look at your data center and look at how BCD can help and NSX can help you optimize your data center, you could always use it with a customer as well, right? Just bring it down to, bring the inputs down into one customer, define the estate and show the customer how they could save and do their bit for the environment within the data center by using the cloud, which is the BCD cloud.
Exactly. Right. That's right.
Yeah.
And that's a very good use case for them as well to use the VMware Cloud Director and the BCD Cloud, as you said. Yeah.
Yeah.
So if you have to talk about this tool in a global carbon emission, point of view and how it can help your business, this tool basically helps users to understand the environmental impact and the carbon footprint of their operations. The tool gives them the flexibility to evaluate what works best for them and how they can leverage VMware solutions in this case as well. VMware Cloud Director in achieving their sustainability goals. So basically, here we are trying to tell them that if you are also using VMware Cloud Director, how best you can amplify your environment and also use this tool to, achieve the sustainability goals by reducing the carbon footprint in their case. So let's try to explain in the upcoming slides what the input parameters looks like and how we are coming to the conclusion. What are the calculations behind it?
Bhaskar, one of the most important things here as well is we're teaching the cloud providers or teaching the customer how they can save resources. But the critical thing here is and not compromise the service performance.
Exactly.
Yeah,
you're right. So basically, if, for example, if someone or the customers or providers, they have got a data center wherein they are using X amount of resources, wherein there are various instances, there are idle resources, they are not utilizing at all. So this tool will, identify those resources. And there might be instances they're using, like, let's say, I'll show in the next slide itself, which can talk about it. For instance, the current environment has X number of VMs, and they, according to their infrastructure and setup, they are using, let's say, 32 hosts. But this tool can also see that, okay, you're using X number of VMs, but you're not utilizing these resources. Why are you using so many ESXi hosts? Instead of that, this can work with 16 hosts. So basically, you're saving 16 hosts. And at the end, you're saving the energy efficiency and the carbon footprint. Keeping in mind, as you said, we are not compromising on the performance of any applications or virtual machines as such. We are just trying to isolate the, the reason behind it and the idle resources and eliminate them. Okay.
And we're looking at as well, so you mentioned hosts a number of times. We're also looking at like the networking components, load balancers, firewalls, etc.
Exactly, that's right.
Yeah.
So as you can see on the left-hand side, we are getting some allocated, available, and the resource subscription here. And so today you're accessing on the bottom right, you can see some of the input parameters which we are talking about. We are asking for the regions, which Amit will be explaining a later part, and what kind of, subscription model, like, or you're using small, medium, large, and we have to put in, and at the end, we'll be getting the allocated, available, and the resource subscription. And the tool will suggest that what's a oversubscription and under subscription of resources, and at the end, how much you can save the number of hosts in that with that CPU and memory which has been allocated.
Okay.
So here as well, this is another screenshot of the tool wherein I was talking in the earlier slide as well, the resource subscription. The core, the RAM, and the storage, we can see we have highlighted in the red, wherein if it goes beyond, like we have got a threshold. So if it goes beyond that threshold, it will be shown up here, that 168%. And also 147, like below 150 is still okay, but beyond 150, we are flagging it as a red, and that's where we need to keep in mind. And here at the bottom, that's what I was talking about, input number of hosts on the subscription 8 average, and also with the NSX, we are getting the number of host count here as well. So this will give us what's the number of hosts which is recommended, and also what the number which you have inputted, and that's where we'll get the savings there itself.
Right. So the tool works out from the inputs you put in and the service parameters you define. It works out what the kind of the default would be of the number of hosts you're going to require. Then you have the option to change that and reduce or increase the number of hosts. As long, and this is the real critical thing, as long as you don't oversubscribe those resources to a point that you're not happy. Exactly. And I think this is a really interesting point, right? Lots of providers, don't use the vSphere scheduling engine as they should do, or to its best efficiency. A lot of providers, they sell a VM of 12 gig, they hard assign 12 gig to that VM, whether it's used or not. And what we can do with this tool is we can say, right, define different allocation models to different VM workload profiles. And if you've got like a large profile, it might be for databases, you want to make sure that's hard reserved, or it's got a low oversubscription or zero oversubscription of RAM. But core, we can always oversubscribe, quite a bit. And there's a safe boundaries, right? Most service providers will know exactly what those boundaries are. Typically RAM is around 120%, so 20% oversubscribed of the actual total RAM. You don't generally want to oversubscribe RAM too much because that some applications are RAM sensitive. But CPU, you can pretty much go to town with sort of almost 200% in many cases. If you're running DevOps workloads, the performance of those isn't important. Massively oversubscribe those. If you're running middleware that you want to ensure is going to be up and running, less oversubscription on those databases, perhaps even less oversubscription. So all of that flexibility is then built into this tool, which is quite a lot of power, really, if you think about it. You're kind of designing your service specification on how you're going to run your services and your workload profiles for your customers to consume. And then getting this output, which you can then fiddle with and change to work out, I've just exceeded, 200% of my core. I need to bring that down a little bit.
Exactly. Yeah. And as you said, it also gives them the flexibility to compare based on the input values which they have given and what we are getting here. Right.
Very cool. Okay.
And let's talk about the output here. This we are getting as a value scorecard, which providers can see based on the inputs and the tool which it gives the suggestion as well. So here we can see the energy saved and the tons of emissions avoided. So this, it gives a very nice graphical representation. For example, if you see on the top as well, the host required for a state without VMware Cloud Director is 30. And then required with VMware Cloud Director and using the subscription model of VMware Cloud Director is 26. And thus the host saved is 4. So basically you're getting a saving based on the number of hosts, that's 4 and 13%. But in real environment as well, this will be a lot more. This is just an example which we have taken. And hence the carbon footprint avoided, we are getting the number here. So imagine if you're using a huge, if you have number of data centers which are using huge amount of resources and host, so this number will maybe way up and that may give you more advantage here.
Yeah. Okay, cool.
And with that, let's talk about we'll give a quick demo about it, and I'll request Amit to take it.
So
Thanks,
just
Bhaskar.
to kind of recap then. So the tool, the calculator, is free for use,
Right.
available to all cloud providers. They just log in with their My VMware account?
Yes.
Yeah. Can you show that, Amit?
Yes. Sharing.
Okay.
Right. So we have this is the Cloud Solutions page. Under the resources section, we have the calculators library.
Mm-hmm.
So we get to calculators library. We have quite a few calculators, and we'll talk about ZCC today.
Okay.
Right. So here we can we find the 5 pillars generally. So this is the input form where it's classified into 5 different categories. The first 4 is focuses mainly on hardware related details. We'll see that in a bit. And the final one details the resources allocation or the resource allocation models, and that is where the VCD capabilities come in. So for this demo, we'll just consider a cloud provider who's in the US, who has about 10 tenants, and his growth rate is about 10% every year he onboards, and then we do it for a 3-year term, and the average VMs on each tenant is about 30. And we have the workload profile here as well. So small, medium, and large. And this is the number of the percentage of the estate that consume that has small, medium, and large. So we'll just make 30% small, 50% medium, and yes. So this is the error. The tool shows if the total is not totaling up to 100%, there is there's a write code error that comes in just to prompt the users.
And this is the, so when the provider's looking at this, so just above that, you can see it's calculated there's 300 VMs in total estate.
Right.
And of that estate now, we're saying those 3 workload profiles, 30% of that 300
is small VMs. That's right.
Yeah.
So, and of course, for this use case, we have considered 228, 416, and 832 to be small, medium, and large. And of course, these can change as well.
Yeah.
But then generally we'll default it to 28 and so on.
Okay.
So we also get the total resource requirement here. We have about 1,200 vCPUs and about 5 gigs of RAM and 57 TB of storage for this case. And next we have the estate and hardware inputs. Here it's fundamentally to ascertain how many hosts that the provider is utilizing currently. So we say about 20 hosts or say 40 hosts in this case. And these are all the physical detailing of the host, physical cores per host, the average storage on a host, and the memory.
Mm-hmm.
We'll just change it to 56. And we also have the VMs on a host. So let's change it to say 40.
Yeah, so that number there, the average VMs per host, that's just like today if you were to look at your state, what is the average number of VMs you run per host? It's usually around 30, 40, something 40. Like that. Yeah,
that's
okay.
right. Yeah. So next we have the operations. So this is the number of system administrators required to see through the operations. We just defaulted at 3. We can change it to 2 or 4 or 5 depending on the case. So let's just keep 2 administrators in this case for this provider. And this is the total effort of these 2 administrators across the operations of the data center. We've classified this into 2 bits. One is the IaaS enhancements and the other one is the network enhancements. And we have considered the broader operational segments like requesting and review, and what's the amount of effort in percentage. Say 10% of their effort goes to requesting a network or a system resource, then defining it, then a change management, a review process, and scheduling the order. So when we change this, the number of hours also change, and this shows what's the amount of hours that each person is putting in.
Mhm.
And here we show the impact of with VCD. So VCD with the IDC research which we did, it showed about 54% increase in efficiency on operational efficiency. So if we've plugged in those numbers to show them the operational gains using VCD,
Yeah.
right? And then you have the saved person's effort, you have the total man hours saved here, and next is the power and cooling.
So those saved persons' effort and hours, that's using VCD, right?
That's right.
Yeah. Okay. Cool.
That's right. So next we have the power and cooling. So this is basically what's the power consumption of the host and the respective related network components in the host. We have about 400 watts on each host, and the power required per firewall is about 10 watt. And this can change, right? This can change if they have a huge load balancer and a firewall. This generally changes, but we just keep it to 10 in this case, considering just the 10 tenants. And we also have the cooling load factor for what's this is generally kept at 1.8, because 1.8 is the general load factor conversion for the cooling. The power required for cooling is about 80% higher than what's required to run. So we'll default it at 1.8, and also the cost per unit. So this can be changed, but then this is defaulted to US value here at $0.01 per kilowatt hour. So this next section, this talks about what is the amount of resources that the service provider requires to layer his differentiated services. Say probably 2% each, or maybe even 10% if he's actually giving a lot of packed services. We'll change it to 10% on each.
So that's reserved kind of compute, which is aligned to other operational systems. So basically, it'll be taken out of the calculation of the tenant's estate.
That's right. So this 10% of the compute, storage, and memory are just taken out of the calculation, and that's just reserved for the service provider's management or whatever console it is.
Hey, Amit, can we just go back to the power and cooling? I just want to zoom into that for a second. So this is where a service provider can put in the average watt of each host that they run.
Right.
In terms of firewalls, are we assuming, does the calculator assume, so that's 10 watts per firewall? Do we assume, per physical firewall, sorry.
Yeah.
Do we assume 2 physical firewalls, 2 load balancers per tenant?
Right. So we have it here. We have it as an input. We can just change it as 2 in this case. Right. It's typoed at 12. Sorry. It's 2 load balancers, 2 physical load balancers, and firewalls. And this is for each firewall.
So that's going to work out per host.
That's correct.
2 for each. Yeah. Okay. All right. So if they wanted to put their total in, they could change something and make it more.
Right.
0.1 per host or whatever it might be. Yeah.
Yes.
Okay.
So next is the resource commitment. So this is where we actually talk to the service provider or give them the use case of how they can utilize the resource. Fundamentally on compute and memory. So a low oversubscription, as I said, guys. So for the workloads in production which require 100% guarantee. So we have about 100% here on both compute and memory, and for middleware where they can have a bit of oversubscription, say 150 in this case on the compute, end and 120 on the memory side. And for the DevOps workloads or the test environment, you can just spin up and take it down as you please at a 200% compute over subscription. So with this defined low, medium, and high, so this might be for this customer, and of course this can be changed, right? So a lower subscription might be 150 for in some cases. So this again is given as an input, but then it's just recommended to keep it at 100, 150, and 200 for general use. And then we have what is the amount of estate that requires 100% resource guarantee. So we just, yeah.
So if I consider low to be like my mission critical stuff, right? I want it to have exactly what it says it's going to have.
That's right.
And I don't care if I don't use it or not. That's what they're going to be hard assigned. So that's like your platinum SLA.
That's right.
So that's likely to be a small amount of your estate, like say
right.
10%. Yeah. And then your medium is going to be like your, I don't know, your application level workloads, your web servers, your file servers,
typical middleware applications.
Yeah, whatever it might be.
Yeah.
And that's going to be quite a substantial amount of your estate. Yeah, most of them are going to be that. Yeah. And then your high would be like the stuff you don't care about. It's not mission critical. Could be DevOps workloads. Could be whatever. Yeah.
Yeah.
Okay.
Yeah, and here we have the number of VMs in each of the allocation series that we have, and we also get the allocated number of cores and the RAM allocated along with the storage here.
And I think what's neat about what Cloud Director does here is we're not considering an individual VM, like we're looking at the whole core.
Right. And so this considers the.
Yeah, that's unique to Cloud Director, looking at that resource pool as a provider resource pool and what's available in the allocation of resources, core, RAM, and storage, like you said.
Yes. So in Cloud Director balance, guys. So this would be the reservation allocation model, and the medium or subscription is generally the resource pool, and then the pay-as-you-go or the flex.
Yeah.
So, and next is the this is where the calculator suggests we have the resource summary here, we have the total allocated cores, we have the total available resources, and what's the resource subscription. So in this case, we have about 37 hosts that's required. That's about
so that's giving what those 37 hosts is giving you.
Yeah,
is
it's the improvement. Yes, yeah. It's the improvement from the 40 hosts that you have. But then again, as you can see here, we have plenty the oversubscription and we have plenty of space to throttle up furthermore. So we have the switch here where you can change the number of hosts that's been suggested. Right now we put in 20 hosts. We'll just halve it and see what's the impact. So it's about 200% oversubscribed on the core and 91% on memory. So 200 is just it's just pushing it too far. So let's just say 25.
I have a question for you. Those oversubscription kind of variables that we're playing with now, are these based on the entire term, including the growth rate?
No, this is for the initial year, which it starts with, and then as you go,
you grow additional. Yeah. Okay.
Grow, yes, that's correct. Yeah. But then the resources here, the allocation model is what is considered a law throughout the period.
Okay. Cool.
Right. So we have about 28. Let's just say 28 hosts. Let us bring it down from the red. So it says 146. It's still acceptable, and
so that gives you a bit of space to breathe. Yeah.
Yeah, and then let's just hit the summary. So here, this is what the use case is. So hosts required for the estate without Cloud Director was 40, and now there's a 30% saving across board. So that's about 28 hosts now. you can do the same stuff. You can consolidate your hosts. You can bring it down to 28, or at least you have the option to onboard new tenants, and with the same amount of resources, you can offer to a higher horizon of market.
Mm-hmm.
And you have the total host saved, about 12. You have the total carbon footprint per customer. It's about 177 tons of carbon saved per customer. Right. So this shows over a 3-year term, about 60 kilowatt hour of energy that's saved from the 12 hosts, and the respective cost of energy, about $2,300 in this case. And fundamentally, this is the use case, right? So the number of trees that you need to offset goes down. It's about 289,000 trees for each customer that you need to offset. From that's the number of trees saved.
So, yeah.
And you also have the CO2 emissions and the greenhouse emissions here. Fundamentally, we are looking at CO2, but then in the phase 2 of this, there'll be greenhouse gases also included.
So this is also awesome info. So not only, using Cloud Director in this model that we've just walked through, you're making a 30% saving kind of across the board on hosts, which directly relates to bottom line for a service provider, which translates to more margin, right? Because they're not going to change their costs; they're just changing the way they're delivering service. So it's more margin overall, but also, you're getting all of these great sustainability gains.
Right. So we just kept it to sustainability here. Of course, 30% savings across board, as you said. So there is financial gain, and on top of that, you can have the services priced accordingly, right? So you also can download this report if you just want to run it through the customer and want to share with him. You have this download summary where you get to see the summary here, right? So here we have the table across board. So the first year, the second year, and the third year, what's the energy consumed for a host without allocation and with allocation, and that accounts to some savings.
Awesome. Yeah, so a partner could use this if they're talking to a kind of a larger customer, say a customer of 200 VMs, for example. This would be a great kind of demonstration of why, they should use the VCD cloud that the partner's got, because they're going to generate these sustainability savings. They're also going to probably save cost and critically achieve the same kind of safety and performance and capability, if not more, with a VCD cloud than they would do with a kind of private hosted cloud.
Right.
That's right.
Very good. Very good. All right. I mean, I think this is fantastic. I love this tool. So it's free for our partners to access it via our cloud solutions site. If you can't remember the URL to it, because no one ever can, cloudsolutions.vmware.com, go to the resources. Yeah, and then calculators.
That's right.
And is there a way of feeding back on the calculator as well, if people have got any queries?
Yes, you on the calculator. Let me share it again. Right, in the calculators page, you have the contact us. You can just write to us here if you have any queries or would want to use it or get to know how to use this. You can just contact us. So this directly sends an email to the VCPP GTM.
Excellent. Okay. Well, I think from my perspective, this is a nice piece of collateral for cloud providers to use. If you are looking at your sustainability initiative, then have a look at the tool. If you're not using Cloud Director, have a look at the tool and see how much Cloud Director could help you with your sustainability objectives. Gents, anything to wrap up on this?
Yeah. One thing is this is really useful as you summarized, guys. So this can be used for greenfield as well as brownfield. So people who are looking forward to use VCD, they can just see what VCD helps them with. And then people who are already using VCD, they can know how they can throttle furthermore.
Yeah, brilliant.
And also NSX.
Yeah, let's not forget NSX. Yeah, I mean,
Exactly.
that whole network virtualization play is, significantly going to save them a lot of effort, having that centralized control plane across all of the networking pieces in the data center. But also, going to save them cost, and like we said, like we've seen, it's going to impact sustainability as well, which is great. Okay, Bhaskar, Amit, thank you very much for your time today. Really appreciate you running me through the calculator and providing all the additional value that these calculators keep on providing to our cloud providers. Thanks a lot, guys.
Thanks, Guy. Thanks so much.
Cheers.